play. Whoops. All right. So, make sure I'm in. Today we're going to be talking about UIKit. So, up to now, we have primarily been looking at language features, fundamental programming concepts, and a couple of libraries. We've looked at the URL libraries and some of the concurrency stuff with dispatch queues. Today we're going to be starting to actually build apps. There's going to just be the one slide deck today. After that, we're going to be coding pretty much the rest of the day. So bear with me. There are still some concepts you should probably understand before we start coding. So UIKit. UIKit is Apple's original way of building app interfaces, user interfaces for apps for iPhone. It was what we used back in 2010. Wait, that might not be quite right. 2013, I can't remember. Basically, it's been around for a very, very long time, over 10 years. As a result, it has some stuff in it that is old. It has some patterns to it that are outdated. It is still a very, very fine way of building user interfaces, and if you ever end up doing iPhone development professionally, you will find especially if you get hired to work on a pre-existing application, it will probably have at least some of it written in UIKit. Apple did release a kind of modern, newer way of doing app UIs called Swift UI, which we will be looking at after spring break. Swift UI is it's easier to write, there's a lot less boilerplate, it's more modern in the way it builds things, it's declarative rather than imperative, and we'll talk about that difference when we talk about Swift UI. But UIKit is still used in many, if not most, Apple iOS apps. Or not Apple iOS, sorry, just iOS apps that are on the App Store. This is because it is still more powerful than Swift UI. It can do more things because it's been around longer. They've stopped adding new functionality to it for the most part, but they still add some stuff every once in a while. But, you know, it's important for you to know how it works. It's important for you to be able to use it and understand it. Because if you get a job working on a legacy app, they will probably ask you to make changes in UIKit for your first task when you start working. Probably debug why a particular, text view is not showing correctly on iPad 4 or whatever, something like that. So, yeah, UIKit, still used heavily in the industry, even if it's not like the new hotness. So we're going to be going over it both today and next week. No, next week is spring. Is next week spring break? It's the one after, right? Okay, cool. Sorry, yeah, today and next week. And then we'll do spring break, and then after that, we're going to do Swift UI. So, yeah. Okay, enough talking about UIKit generally. Let's, dive into it and actually, look at some stuff. Oh, you know what I need to do? I need to actually plug my clicker into my laptop. Actually make sure it works. I'm sorry, guys. I'm off today, Out of it. Give it a moment. There we go. Okay, cool. So, in UIKit, you use things called views and controls. These are your building blocks. They're kind of the Legos that you construct your screens out of, okay? So, basically, views are kind of a catch-all thing, and controls are a special kind of view that the user can interact with and do things with. You have a few examples up here, and we'll be looking at those in more detail. But yeah, this is basically, how you build apps for iOS. So let's look at a bunch of different views that you can use. This is just, right now I'm just going to give you a quick overview of a number of the views that are the most common, just so you know what exists. You'll find when you're working with frameworks that are as large as UIKit and Swift UI and as extensive as them, that the discoverability is pretty low. So just being exposed to what exists is a very helpful process. It lets you know what's out there, and then you remember, oh, right, there was a, that's right, Professor Dan said there was a thing, some sort of slider thing, and then you can look it up and actually use it later. So first, text views. These are views that can display and input text, okay? The first one, a UI label. That is just your basic single line kind of piece of text that you show on the screen, UI label. Next one is a text field. Text field is this guy in the middle here. Text fields are basically input places for a single piece of text, a single line of text. If you need your user to put in their first name and last name, you would use two different text fields, one for the first name, one for the last name, right? Pretty simple. And then the next up is the text view. This is for a larger block of text, possibly formatted. If you're getting a big piece of data from like a big text block from your service that you want to display, then you'd use this. It also allows for editing, so you can also have a text view be a very large input field for users to either modify some text that already exists or put in a bunch of text that they are creating whole cloth. So yeah, these are some of the different views that you can use for text modification and display. Next up is content views, okay? First of all, we have the UI image view. This is how you display images and put memes inside of your iPhone apps because everyone likes memes. Next up is the activity indicator view, also known as the spinner, which, if you'll recall, is the most important view in the entire library. Because without a spinner, how can your users know that you're actually doing something in the background? So you need to have a spinner. Anytime you're trying to do something, you should always have a spinner somewhere. And that way, they look at the spinner and they think, the spinner is spinning. The app is clearly doing something, even if you're not, right? So that's what the spinner is for. And then lastly, the progress view. You can use a progress view in place of a spinner if you really want to. There's other uses for it as well. It's just a nice way to display kind of a, two pieces of kind of color and have one kind of be somewhere in the range of the other. But if you use it for actually showing progress, users tend to expect those to actually match your progress. But as we've seen with async await and network requests, we only have a few places where we can pop in and update that progress view in a way that's realistic, right? We could, when we send off the network request, move the progress view up to 25%, and then when we get back the network request, move it to 75%, and then when we decode the JSON, move it to 100. But at that point, you're not getting the granularity that a user might really want, so it's better to use a spinner in that case, or activity indicator view. And then lastly, we have controls. Not lastly, sorry, I think there's one more after this. Next up, we have controls. These are specifically user interaction views. Two of the text views we looked at do have the possibility for user interaction, so it's not like these are the only things that can have user interaction. In fact, you can configure every single view that exists to take in tap inputs. Yes, what's up?
For the last page, the view I want to ask is all in the screen. This concept means in the screen or behind the screen, in the code or somewhere. This concept. Like the progress view. Do you mean is that on the screen? This one?
Yeah.
You mean show on the screen, not behind?
Okay. Yeah, it will show. So the question was, does the activity indicator view or the progress view, do they show on the screen or go in the background? Is that? Yeah, yes, they show on the screen. So these are things that you draw so that the user can see them.
Okay.
Yeah, yes. Yeah, so these are all, yeah, views are all things that you show on the screen for users. Right, so controls are views that are specifically designed for user interaction. You can make every single view user interactable, and they can all receive touch inputs and stuff, but these ones come with a bunch of fun helper methods that allow you to really use them effectively without having to rewrite the wheel and handle the inputs yourself. So the first kind is a button. You press on it, something happens, okay? Next up is a UI switch. This is actually a subclass of UI button, so it's a form of button, but it's a special kind of button that switches between off and on. Regular buttons have different states for being disabled, enabled, highlighted, and pressed. But if you want it to be toggleable, you'll probably use a UI switch instead. Next up is a slider. This is just something where you drag back and forth when you're modifying your volume or any like brightness or whatever. That's usually a slider. And then a segmented control. This is kind of a special button where you get to pick between a bunch of options that are sort of in a horizontal line. You just pick which one you want. There are many, many more types of controls. These are just the ones that are kind of, cool, interesting, important, helpful. I was wrong. There was not another. Okay, cool. So UI view. So every single one of these views that I just showed you all are subclassed from UI view or they're subclassed from something that is subclassed from UI view. They all inherit from UI view in a strict kind of class inheritance method, right? So at the very top, you have this thing NS object. That's like kind of the basic, Objective-C object that exists. If we were talking Java, you could call it an object, right? Same thing. Then there's this UI responder. We'll talk more about responders in a few slides. Then there's this UI application, UI view controller. You can ignore those for now. Then you get this UI view, right? Okay. And then after that, you have all these other things, right? The control, label, image view, button, slider, switch, text field, scroll view, right? You'll note a bunch of these things actually inherit from UI control, which means that things that the UI control class creates and gives you are available on all of those types as well. So they come with, basically all UI views come with a number of functions and properties that are very, very useful, such as is hidden. This is a Boolean property that if you set to true, hides your view. If you set it to false, your view draws. It's that simple. Is user interaction enabled? This is another Boolean property. As I mentioned before, you can, for every single type of UI view, you can set user interaction enabled to true. There's also two properties. There's one called frame and one called bounds. These have the X and Y coordinates and the width and the height. They are in different reference frames. The frame property is in the reference frame of the owning view, and we'll talk about that and the view hierarchy shortly. And bounds is within the view's own reference frame. That distinction is not super important, but basically it's kind of how you figure out how big your view is. So views in UIKit get laid out to the screen and rendered in particular ways. There are a few ways that you, as a developer, can make sure that your views show in the order that you want them to. What you can see here is something that's called layout constraints or auto layout. Auto layout and layout constraints are the way that UIKit primarily handles making sure that your views are where you want them to be on different sized devices and different orientations of devices. The entire reason why we do things this way, rather than just saying, oh, right at this pixel coordinate and be this size, is because iPhones change dimensions every year. And we need to be able to handle that year over year without changing our views every single time. So we have three different kind of ways of doing layout constraints here. There are many, many more, but these are the ones that are kind of helpful and important. So the first are position constraints. There is the center X and the center Y constraint. So you can constrain a particular view. You can say, hey, I want your center X and your center Y to be kind of equivalent to these anchor points, you know, or a multiplier of these anchor points. For example, this first one, seriously guys, image is anchored such that its center X, which is the horizontal, okay, which means this vertical line, right? Its horizontal position, which is shown by the vertical line, okay, is constrained to be the same as the center X of its containing view, which is the whole screen. So they match, they're the same. Therefore, it's always going to be centered, no matter how big the screen is, no matter how small the screen is, that view will be centered in that horizontal kind of plane. If you look at center Y, which is, you know, the up and down, right, the vertical, this is clearly not centered to the same exact center Y as the super view. It is offset by a certain amount of distance. Now, there's multiple ways you can do this. You can do this with multipliers. You can set up anchors. You can do it by a certain number of points. Apple prefers to use points rather than pixels because they have retina displays versus non-retina displays and 3x versus 2x displays. And they do all sorts of weird stuff with pixels. Don't worry about it too much. They're just called points. You can think of them as pixels. So yeah, that's the center Y. And that adjusts where it is vertically in the screen. So the next kind, our guys image, has a width and a height constraint set. So by default, it will, you know, UIKit will kind of try and guess sort of what size you want it, you know, the views to be. And it will try and show them in the way that it wants, but there are some views that just won't render if you don't set a width and a height for them. Now, you don't need to set the width and the height to a specific pixel value. You can say, oh, I want my width to always be the same as my holding view's width. Or I want my width to always be the same as this other view down here's width, right? You can match these things up together, and that allows it to, you know exactly how big it should render the element, or the view, sorry. Yeah, so that's what width and height look like. And then finally, for the seriously, we have our edge constraints. So you can, instead of using width and height and, you know, center X and center Y, if you want, you can use these edge constraints. You can also use any combination of these things in total, as long as Xcode and UIKit and the framework can figure out, as long as it has enough information, your stuff will display correctly. You just need to make sure you give it enough information. So these constraints here, the edge constraints, basically say, okay, cool, so I want to have my top edge be equivalent to, or, you know, greater than or equal or less than or equal to an offset from some other edge, right? Some other edge that exists, okay? So in this case, this one down here, seriously, is set to be offset from the bottom of the guy's view, image view, edge by 20 points, okay? And it's set to be, for the leading edge, we say leading and trailing instead of left and right, specifically so that our app will work correctly in a right to left reading context as well as a left to right reading context. So you can use left and right, they do exist. Don't. It means that your app will not be localizable to a language that uses right to left reading, of which there are many. So use leading and trailing. They are preferred. So here the leading edge is constrained to be 20 points from the leading edge of the super view, the constraining view, the view that it's within. The bottom is set to be 20 points from the bottom of the super view, and the trailing is set to be 20 points from the trailing of the super view, okay? So interesting note, the value that you set, the constant that you set for each of these constraints and we'll see this when we do the constraints and code later in the workshop, is usually going to be positive. Unless you want things overlapping, it's just the distance between them, not the direction. You're not specifying a direction, you're specifying distance, okay? And if you make it negative, that's saying they overlap, not that they have any distance. Okay, cool. And constraints will make more sense when we actually like mess around with them in Xcode. So, yeah. Another way that you can arrange your views is using container views. Views can have views inside of them. I kind of referred to that with the layout constraints. My slide order is kind of wonky here. I probably should have covered that earlier because that'll be coming up shortly, but whatever. So you can place views inside of other views. You can nest them as much as you want, much like scope. When you do that, you can do it with particular kinds of views, special kinds of views that are called container views, much like how controls are special views that take user interaction, and content views are special views that display content to the user. Container views are special views that correctly arrange their subviews in particular orders and ways. So here are 3 examples. First, we have a stack view. Stack views are a great way to arrange your views if you are not expecting it to change at runtime. If you're expecting it to just be, yeah, we're always going to have 4 labels here in a row, that's never going to change, nothing the user does will modify that, that's just always how we're going to display it, use a stack view. That's what they're for. Non-changing view layouts. Next up, there is this thing called a scroll view. I don't actually have a scroll view in here because the next 2 have a scroll view baked in. Scroll views are weird. Scroll views are hard to use. Scroll views are fiddly. We're not going to mess with them too much in this first lecture. But basically, scroll views are a way to have a, you define the width and the height and everything of the scroll view, and then any subviews that it has within it, you can scroll to view them if their extents go beyond the extents of the scroll view itself. So you can scroll within to see. It's kind of like having a window into a deeper layer of your view. It's a good way to think about it. Next up, though, in the middle here, we have UI table view. This looks very similar to our stack view, but that's just because of how I've set this up. You'll see here, this thing that says prototype cells, and it has label, label, label. These are what are called table view cells. Table views are a way of doing a very simple list of views of things that you want to display. And the way that it works specifically is it uses kind of a reusable view pool so that you can kind of infinitely scroll without crashing your application. So you can infinitely scroll and the memory won't keep going up as you get to more and more things. As stuff gets further and further off the screen as you scroll away, it will get dequeued and disappeared and then reused later on and reconfigured by your code. We'll be looking at table views in more detail probably next lecture. So, and then also collection views, they're very similar to table views. However, rather than being just a kind of a row or a series of different cells and rows and stuff, they can handle all sorts of different layouts. So they can handle kind of grids of things. If you've ever used the Photos, the media Photos app, right? When you have that kind of grid of all your pictures and stuff and you're scrolling through it, that's probably a collection view, right? Collection views can also handle like differently sized, things, right? And it'll just, flow things around it all correctly and everything. And it handles all the constraints for you. You don't have to mess with it. You can configure it. There are some properties on it that you can, set to make it behave in a way that you'd like, but it is pretty fixed and locked down. All of these are. You're not, when you're placing views inside of container views, you are typically not setting many or any of the constraints within on the views that are within the container views, because the container views are creating the constraints for you. And it will probably delete and override any constraints you set, so don't waste your time. Okay. Oh, here's the view hierarchy. Yeah, that's what I should have had much earlier. Okay, so in UIKit, views can have any number of subviews. So you can create a tree of views. Basically, every single view has a property on it called subviews, and it is an array of UI views, right? And you can have that be filled up with any number of views that are, inherit from UI view. When you place things within subviews, they inherit some properties of their super view or parent view, right? If you hide a parent view, then all of its subviews and all of their subviews will get hidden as well. If you set the parent view to have user interaction enabled, all of the children will set that as well, right? There's a number of things like this. You will learn them over time as you do it. Just remember that some things are inherited. In addition, the order of the subviews within a view determines the render order, okay? So the parent view always renders behind all of its children, right? Now, if any of the children overlap, right, then those children, the render order is determined by the order that they are in the subviews array. So order matters if you have things that are overlapping and they, basically render, you can think of it like they render from the bottom up. So, or from the top down, it depends on how you think about it. But basically, your kind of rootist, your highest up view renders first. And then the next ones down in order render on top of it. And then the next ones down render on top of that, and so on and so forth, right? As you can see here, we have this view A is overlapped by view B in this diagram, and that's because view B is the second item in the array of subviews underneath the main view, which is this big white box that holds all of the views within it. The other thing to note is that subviews can be clipped within the UI views bounds. So this isn't necessarily guaranteed. This is not the default. By default, if you add a subview to a view, you can draw it outside of the bounds of the parent view. It doesn't care, right? The parent determines things like the reference frame. So if you move the parent 5 pixels to the left, all of its children will move 5 pixels to the left, even if they're not fully contained within its frame, right? They're just kind of tied together in that way. But if you set it to, there's a setting that you can do, I think it's like clip subviews, it's a property you set to true, then it will only render subviews if they are within the frame of the parent view. So only if they have portions of themselves that are within the frame, then they will render. Again, like a window into a world that doesn't actually exist, and you can only see the things that are within the viewport of the window. One thing to note, view hierarchy does not automatically position things. So it does not handle the constraints. It doesn't set up auto layout. Only some views do that to their subviews. That's views like stack view and table view, things like the collection view, things in that previous slide. They all handle having their subviews arranged and set up in particular ways. But if you add just a random view to a random other view, its position doesn't get modified by doing that. It doesn't get constrained. It doesn't get snapped into a spot and put in its particular way, right? If you add it to a stack view, the stack view will say, oh, cool, come here. I'm going to put constraints on you. I'm going to put you in a box. I'm going to make sure you're inside of me and that you're going to be so big and so on, right? So that's something to keep in mind with the view hierarchy. There's also this concept called the safe area. Basically, since Apple added some nonsense, right? You recall, maybe you won't, back when iPhones had buttons on them on the front, way back in the day. It was less important then. It's much more important now because you have these, this little thing on the bottom that kind of indicates, oh, if you swipe up, then you can get functionality. Or at the very top, you have your time and your, all this stuff, but then you have the island, right? And things render around it, right? Basically, there is this concept called the safe area, and that is a set of edges around a particular, like within a view, that its subviews can use for constraining themselves. So if you want to match your leading edge to the edge of the screen, perhaps consider doing it to the safe area instead. Or trailing edge, for example. We have a custom view over here on the right-hand side. Let's say we wanted to set this up with a special status bar on the bottom and the top, and a special kind of navigation mini-map on the right, okay? Something like that. Doing so, we want to make sure that any of our subviews, any views that are contained within us, have a way to constrain themselves safely to make sure that they don't override or draw over top of any of our navigation stuff that we've added, right? To do that, you can modify the safe area for your view and say, oh, my safe area is not actually my bounds. It's a subset of my bounds here. The top safe area is actually 20 points in, the right safe area is actually 30 points in, and so on. It's kind of like margins, but it's not margins. Margins are actually a different thing, so don't worry too much about that. Yeah, cool. Good. Okay, receiving input. So, when you are receiving input on an iPhone, or iPad, or Mac OS, or whatever, basically, UIKit has this concept called controls, which we talked about, and it also has this concept of targets. Targets are something that you can point a control at and say, hey, this class instance over here, this particular piece of active memory, this is my target. This is where I want actions to go, right? This is where I want them to land, okay? So you can set a target for specific input events. So you can say, okay, if I get a touch, then I want that event to go here. I want to route it to this object over here and this function on that object, right? If I get a multi-taps, twist gesture or whatever, I want that target to go to be some other object, and I want it to call a different function on it, which is its action, right? Yeah. There's a bunch of different ways that you can set this. We'll look at those in the workshop portion. Yeah, it's something to keep in mind, is just how UIKit kind of thinks about sending events to particular things. How you as a developer using UIKit can tie together particular actions that users can perform to particular pieces of code that you have elsewhere in your application. These are a couple of the different ways that you can do it. So we'll look at these in the workshop, but there's something called IB action. There's this add target action for function, and then you can also create a UI action, which is kind of the new hotness, but I say new hotness, it's like 6 years old. Yeah. Okay, so speaking of input events, there's a number of different input events that exist in iOS. So for example, here is the touch input event. And specifically, touch has many, many different components to it. It has a moment when it begins, which is when the user first taps. It has a touch moved event, which gets fired whenever the user drags their finger around, once they've touched. There's a touch end event that gets fired when they let go. And there's a touch canceled when some other thing happens and takes over the screen. And even if they're still touching, right, your element, the thing that you were reading, it's not on the screen anymore. So the touch got canceled instead of ended, for example, right? Like someone gets a phone call and then it comes in, right? There's also gestures. So there's a bunch of different gestures that you can use. There's the tap gesture, which is very similar to those touch events. And It's not exactly the same because once again, it's an older API, so there's about 5 different ways to do every single thing, but it's similar. So there's tap, which is about 0.1 seconds of just a press. There is a long press, which is anything longer than 0.5 seconds. There is panning, which is where you touch and then drag. There is swiping, where you go from one side to the other, kind of mostly horizontal, right? There is pinching, where you kind of have 2 touches and they go in and out or in and out like so, like when you zoom on your phone, right? That's a pinch gesture. And there is the rotate gesture, where you have 2 touches and then you spin and rotate. These are all different gestures that you can use UIKit's gesture kind of framework to access and tie to your views, listen for them on your views, and then change your views based on the inputs that you get.
Professor?
Yeah.
I feel this is very interesting because before doing the web development, I just click the button. I know there is a real things. And when I click the button, it's connect to the development of web. But the phone, when we click, this also belong to the concept of Swift. I think this belong to the hardware.
Belong to the what? Sorry?
Hardware.
The hardware? Yeah. Yes. So like a lot of these gestures, specifically the 2-touch gestures, primarily you only get on like iPhone, right? Or not only on iPhone, right? Like Android has them now too, right? But capacitive touch screens are the only ones that can detect multiple touch events simultaneously correctly. There used to be different kinds of touch screens, which were all typically really, really bad. That like looked for shadows or other kinds of touch, or like actually felt for like actual presses, like those really old ones that you'd have to like really jam down on it, in order for it to like sense what you were doing. Capacitive touch changed that and made it so that you could have multiple different touches all being read simultaneously. Yeah.
So in our Swift iOS development, mobile development, when we're doing the development, we know the users where they push and touch. We can know that.
Yes. So the question was, when we're doing the iOS development with Swift, do we know where the users touch and press on the screen? And the answer is yes. So if you add, there are different ways to check for it, but one of the ways is you can add gestures to your to your views, to your screens. And you can, if you add a gesture detector, right, and say, hey, if the user does this gesture, if they swipe, or if they spin, or if they pinch, send me that information. Tell me where they started touching, tell me how far their fingers moved apart, how quickly, that sort of thing. And it will give you that information, and then you, as a programmer, can use it to make your app respond in a way that makes sense. Cool.
That's very interesting.
Yeah, it's cool. It's dope, as they say. Right. So a lot of inputs come through what's called the responder chain. Basically, when an event comes in, it goes through this view hierarchy, right? But it goes through it from the bottom up. So you'll note that this view hierarchy looks a little bit flipped upside down from the previous ones we've seen. That's because you typically start with your leaf nodes of the view hierarchy. The things that are drawing the most on top, right, are the things that we check to see if they can handle that event first. So most UIKit types are responders. They all inherit from that UI responder type. We saw that in the class hierarchy before. And because they're responders, they can handle input events. When an input event comes in to the UIKit framework, the first thing that UIKit does is it searches the view hierarchy from the bottom to the top and bottom to the top. So from the bottom to the top of the tree of the hierarchy, which to the user is basically the things that have rendered on top, right? The things that are visible, the most visible. it searches through those first, and it tries to find valid responders for the action. So, like and that what is a valid responder? It depends, right? First, the responder needs to actually be set up to respond to that kind of event. So, for example, a UI label might not, if you don't have user interaction enabled, it won't be set up to handle a tap event unless you specifically add it, right? Same thing with a text field. A UI button can typically get taps by default, but maybe it doesn't know what to do with a pinch, right? But if you were, instead of using UI button, using some custom subclass you created called UI pinch me button that adds a gesture recognizer for pinch events, then the pinch event would get caught on your custom UI pinch me button, and then it would essentially, recognize it, and then you could do something with it, and it consumes the event. Of course, there's other constraints as well, right? It needs to happen within the bounds of your view, right? If you tap over here, it's not going to be checking a view that's over here, right, necessarily. So there's a bunch of things, but basically it looks through the tree for something that can handle it. And if one of the views that it checks, one of the responders it checks, doesn't know what to do with it, it just moves on to the next one. And once again, it does this in reverse order from the render order. Okay, so we render from the top of the tree down to the bottom and from the left to the right, right? From our earliest subviews to our latest subviews. And when we're checking responders, we do it in the reverse order. So we start from the very bottom right side of the tree, we go left and then up, right? So we just basically go through until we find the first responder. And this is an actual term that they use in their documentation all the time. So if you see first responder in the documentation, what they're saying is the first UI responder that actually can handle the input correctly. You won't run into this too terribly much unless you're doing a lot of text input. When you do the thing where the keyboard comes up over your screen a little bit and kind of, takes over a portion of it, right? It's being presented on top, but your screen is still existing in the background. When you start to type in stuff, all of the UI documentation talks about how those typing events are being sent to the first responder, which is basically, the most important top view that can handle them at the time. So anyway, that's the responder chain. It's good to know how it's working, especially seeing as the documentation refers to it a lot. But it's not super critical, but it is helpful to know that, like, if you have a button and then you have another button under it for some reason, like rendering underneath it, you would expect the button on top to be pressed only and not the button underneath, right? And then if the button on top is smaller and you kind of go outside of it and press the button, the edge, then you can press the button underneath it, right? Things that you would intuitively expect to be the case, right, as a user. But as programmers, we can't just be intuitive. We actually have to understand and, write it all out that way, right? So knowing how that gets handled and written out is helpful. So next up, we're going to talk about the model view controller pattern. Model view controller is a way of handling the combination of displaying information to a user and also receiving input from the user and running and handling business logic and modifying business data. This is a design pattern that exists specifically to handle a problem that has existed since we started to have graphical user interfaces, which is that business logic, the performing operations, calculations, network calls, database writes, all the things that we do as programmers that aren't drawing stuff to a screen, tends to not play nicely with drawing stuff to a screen. if you try to do all of it on the same thread, for example, you will have a very, very laggy screen. Every time your user does something, there will be a huge delay as you write to the database, hit the network, wait for a response, all that stuff. That's why we have threads, primarily. Unfortunately, though, threads added all those other issues that we've run into, right? So design patterns are a kind of template for how you set up protocols and types like structs and classes and stuff, how you arrange them together in common ways. There are a number of them that are specifically designed for handling graphical user interfaces, and MVC is one of them, and it is the one that Apple has chosen for UIKit, okay? UIKit uses MVC very explicitly and very strongly, constantly everywhere. It's very hard to write a UIKit app using a different GUI design pattern than MVC. Other ones include MVVM or VM or whatever, right? There's a bunch of them, right? But MVC is what you use for UIKit. So in the model view controller pattern, models hold your business data. Things like user information, just the things, just your data types, right? Views hold your display logic. This is how do you draw to the screen? What do you render? What color are you? What does that mean? What does color mean? Well, when you're dealing with pixels and light, it's RGB, but if you're dealing with pigment on paper, it's CYK, right? Like color is its own nasty mess, and we're not going to get into color. But basically, views handle all of that because there's a lot that goes into how do you render to a screen. So we have the business data being stored in our models, we have the views handling how to draw stuff to the screen, and lastly, we need something that combines those two things together in a holistic way. That's the controller. The controller holds business logic so it can execute and run, logic that mutates and changes the data. And it also handles the display context. It can tell the views what they should display and how they should display, which ones of them should display, etc. Right? This pattern looks kind of like this. You have your controller. It's sort of the thing that's running the show. It's got your business logic. It handles combining your pieces of data, whatever. Right? Let's say that we have a bunch of stuff that we're displaying to the view. The user decides that they want to delete something, okay? They press the delete button. That information gets sent to the controller. The controller receives it and says, I see, we must delete this thing. I understand. Let's go ahead and try and delete it and make sure that we can delete it. Also, when we delete things, we have to make sure that this widget fires and we send this notification, and we also make sure to put this log event into our log file so that if this causes the program to crash, the developer can actually figure out what went wrong, right? So basically the controller handles all of that, like the knock-on effects of the user wanting to delete something. And it also tells the model, hey, by the way, could you please delete yourself, right? This particular entry in the model, I'd like it deleted, right? The model will then respond and say, yes, I was able to delete it. Or, oh no, I wasn't able to delete it. Sorry, this was a piece of undeletable data, right? And then the controller decides what to do with that. It says, I see, okay, so it was deleted, excellent, very good, well done. We will now tell the view, hey, you can not render that piece of data anymore. And then the view might do some cool animation where it slides the piece of data off and then does a little fireworks display, right? You don't know, you don't care, right? That's not the controller's view, purview, that's the view's purview, right? Or the controller will get back the notification from the model, oh, this wasn't deletable. Sorry, you couldn't make any changes for whatever reason. And now the controller says, I need to let the user know that there was an error, that something didn't work right. So instead of telling the view to delete the thing and remove it, it tells the view, hey, display this particular error to the user and let them know that they couldn't delete this thing, right? So yeah, your business logic, which is to say most of your code, will live in the controller. Anything about displaying and animating will typically live in your views, and anything about storing, and maybe some of your mutation of your model code will live in your models. Specifically in UIKit, this is what that looks like. There's a bunch of stuff in here that will make, more sense later or will never make sense, right? But essentially the thing to note is that you have a bunch of view controllers in your app, and they modify a number of documents and data objects in the model. And then they are also owning and controlling a number of views and UI objects in the view. So yeah, this is kind of the breakdown of what it looks like specifically within UIKit. So the UI view controller. This is a class type in UIKit that all view controllers inherit from. Much like UI view, where all views inherit from that, and subclass from that, all view controllers will subclass from UI view controller. It is the bridge between UIKit and application logic. So it is how you connect the things that you want your app to do to UIKit's library. That's all done through view controllers. Each one has a root UI view. Every view controller has a property called view. And every single view controller, when it is presented, displays that view. It renders that view and says, cool, hey, here's my view, send it off, right? Whenever you are constructing a screen, you will basically be adding to the subviews of the view controller's view. There are two kinds of view controllers. The first is the content view controller. That's this guy here to the left. It's got that root view, as I mentioned, kind of behind this image view, right? And it's kind of a terrible image, but it's the sort of basically that white background that covers everything, right? And is rendering over all of it. That's your root view, okay? That's the myViewController.view property, right? And then within it, you have your subviews and stuff, right? The other kind of view controller is called a container view controller. And container view controllers manage other view controllers. They tend not to have a view or deal with a view themselves. They primarily are used for determining how to display other view controllers. They do things like having a navigation bar in the top or having a bunch of tabs on the bottom that you can switch between, right? That's what container view controllers are. We'll look at those shortly. So first, content view controllers. Typically, when you are designing your application, you will have one content view controller for every single distinct screen in your application, okay? When you have one whole screen that's kind of, maybe you scroll up and down in it, but it's like one piece, and then whenever you tap on something, then it kind of slides to the side and something new shows up. That new thing is typically going to be a new view controller, and what you have on the screen before you tap that is all within the same one view controller, typically. Content view controllers are the kind of view controllers that are concerned with your business logic and your data models, as I mentioned before. Here are a number of examples of content view controllers you might create. Tabular interfaces, which is kind of a list, a row of pieces of data. A grid interface, right? That it's a grid of a bunch of data. You'll recollect that there was something called a table view, which looks a lot like this thing to the left. And there is also a table view controller that's view property is always a table view, right? That is next class. The grid interface looks a lot like a collection view because there's also a collection view controller. And the one on the right looks more like a kind of custom thing that you might build yourself, right? A data entry interface. This is a bunch of things that you just put in and arrange in a way that you want using layout constraints. Your content view controller tends to have a bunch of data objects that it's modifying and working with, and then it has its root view that has a bunch of subviews within it. Oh no, my animation's turned off. Oh well. Container view controllers are, as I mentioned, concerned with navigation and the structure of your app. They're mostly about managing content of view controllers and presenting them to the user. Pushing things from the right to the left, popping something up, displaying a modal, right? All of these things are handled by container view controllers. And they are basically a way of rendering at a high level rather than a low level. Views are kind of your more granular piece, right? Container view controllers are how you navigate through an application. There are a number of them that UIKit gives you by default. There's the split view interface, which has a detailed view on the, or sorry, like a list view on the left and a detailed view on the right. It's mostly made for iPad, although typically they want you to use that instead of a navigation controller now for iPhone, but that's a different discussion. There's navigation interfaces, which have a stack of view controllers, and they push onto the stack whenever you navigate forward to the next thing, and then you can hit the back button and pop off. There's the tab bar interface, which has a bunch of different tabs that you can switch between. Those switch between different view controllers. However, the one view controller on the outside, the tab bar view controller, is going to remain the same, and then it just presents view controllers within itself differently. And then the paged interface, which is basically, again, it's similar to the tab one, but it's intended to be for, rather than having button presses, you swipe, and as you swipe, you move to new view controllers. Typically, this is an example. You'll have your root view controller in your UI window. Windows are another thing they added that only really matters for iPads, so we're not going to look at them too much. But UI split view controller, for example, we've got our split view interface here on the left. And then it has within it a navigation controller, right? And that navigation controller handles, navigation, right? And so within one of those two panes, you can navigate and push stuff onto the stack within that pane. And the other one, there's just one regular old view controller that maybe you defined or did a subclass of. And that's just rendering a bunch of random stuff, right? And it never navigates, it never pushes anything onto a stack, and it just kind of stays there statically while the other one kind of pushes onto the stack, right? And just builds itself up, right? And you can nest these things in all sorts of fun ways. Although typically, for the most part, you'll use navigation controllers within these other ones. So, cool. View controllers have a life cycle. So when a view controller is going to show up for the first time ever, then there are a number of methods that it will call, okay? So view controller is a UI view controller class type. You, if you want to create a custom view controller, will be subclassing from the UI view controller class. There are a number of methods that UI view controller wants you to override. If you override these methods, then your override method declarations will be called when certain things happen, okay? So these are your life cycle methods. They're called when the view loads, when it appears, when it disappears, that sort of thing. You override them to run your custom code when those events occur. Got ahead of myself again. Primarily, of all the methods, the one that you will always use whenever you define a custom UI view controller, every time, is viewDidLoad. ViewDidLoad fires when the view controller is first loaded into memory and is getting ready to render to the screen. It has not yet appeared. It has not yet rendered. This is where you do all of your view setup. This is where you add your subviews. It's where you create your constraints. It's where you make sure that everything is in place and ready to go so that you can present a screen to the user that makes sense and works correctly. You do not do this in the initializer. Typically, with a lot of other classes, you'll do that kind of preparation work inside of the initializer of the class. You do not do that in the initializer of view controllers because there's a bunch of work that has to happen before adding stuff to the subviews array and creating constraints can happen correctly, right? So typically, you'll do most of your definitions in viewDidLoad, and we'll see that when we do the workshop as well. Here's a bunch of the different events that occur and the things that cause them to happen. These are view will disappear, view did disappear, view will appear, view is appearing, view did appear. These are for things where If the view controller, gets pushed out of the way and a new one gets put on top, or something is drawn modally over it, then it will disappear, quote unquote. If it's not visible on the screen anymore, it disappears. But it will typically remain in memory, and view.didLoad will not get called again when you come back to it. As long as it remains in memory, then view.didLoad doesn't call back. If it gets released from memory, then view.didLoad will get called the next time that screen displays, right? Yeah, so view controller lifecycle. Helpful, you don't need to memorize it. So the delegate pattern, we talked a little bit about the delegate pattern when we were talking about protocols. They use the delegate pattern like it's chocolate chip cookies in UIKit, okay? It is everything, it's everywhere. We will see a lot more of the delegate pattern in class 2 for UIKit. When we start to look at table view controllers, collection view controllers, they make such heavy use of delegates that it bears mentioning as we're doing an overview of what UIKit is, right? But essentially, basically, the main thing that delegates get used for is for screens to communicate with the screen that pushed them onto the stack, that showed them to the user. So if you have one screen that shows a bunch of options for things to change, and then the user taps on one of those things, and that then pushes that one off to the left, and a new one comes on from the right, and that new one shows a bunch of ways to modify that particular field, right? To edit it, right? Typically, you don't want to be like passing into that a data object and then trying to get it returned back to you exactly, because all of this is happening in a sort of event-driven way, right? This is all being done via method calls that you can't control the function definitions of. So you can't say, oh, present this view controller, but make the return type this data object I want, right? That's not an option for you, okay? So you have to call, oh, present this view controller, and then also set myself as the delegate so that when it finishes what it's doing and it knows what it wants, it knows what the user wants, and they've hit done, they've hit save, take whatever was in that text field and give it back to me. And the way you do that is with the delegate pattern, where you implement some methods that screen A implements a bunch of methods that screen B is expecting to be able to call once the done button is pressed, and then it does, and it sends that data back, and then screen A gets it, and it can make sure that it's modified and ready and in place before screen B gets dismissed and screen A renders again, so that you always see that data correctly in screen A. And that's the lecture for UIKit. After this, we're going to be looking at actually writing code in Xcode. So any questions about any of this before we do our break? Cool. Okay, awesome. I think this is the 10-minute break. Yes, so take 10 minutes, get a snack, drink, bathroom, whatever.